Hello, hello, Pradeep. Yeah, I am audible. Hello.
Hello?
Yes, you are audible.
Okay,
Yes,
okay,
sir.
okay, okay. Thank you. Let's wait for another 5 minutes. Then we'll start our session because some people will join. I think. Okay, now we will start our session. Uh, I think I'm audible to everyone.
Yes, you're audible.
Okay, okay. Now my screen is visible in full view mode. Hello.
Yeah, looks good.
Okay, okay. Now we'll move first on the question answer session, or then we'll go for some concept and all. Basically, our lecture one was about the uh, basic concept of fluid, and the second one is the properties of fluid, and the third lecture was about the fluid flow analysis. So now basically here I have followed the Sinjal Simbala book for the question answer session, and another I am using for previous year questions, assignment question, basically NPTEL fluid mechanics previous year assignment question, so that it will be help for your the coming assignment in this year, the fluid mechanics. So we'll first we go for the question answer session, then we'll go through some concepts about. Now I think the first and second questions is visible to all of you. Hello.
Yes, it is visible.
Yes, please. So you can chat box. You open your chat box and answer the question number one and question number two both. Please within 2-3 minutes. Just very simple questions. The first question is about the in Newtonian fluid for a given shear stress, the rate at which fluid deform is. The first option is independent of kinematic viscosity, and second one is the directly proportional to the dynamic viscosity, and third one is inversely proportional to the dynamic viscosity, and the last one is the none of the above. So please within 1 or 2 minutes you can just write the answer of the first question in the chat box. And if you have any doubt regarding the first question, you can ask. And so please, everyone participates in this session. Then we will feel some fine. Otherwise, okay. The Pradeep is saying the for the question number one is option number B is correct. Okay, let's see. And directly proportional to the dynamic viscosity. And another one. Yeah, for second one is a fixed region space. Okay, I think it's fine. For first question is directly proportional to the dynamic viscosity, and for second one, the control volume is implied like a fixed region in space. And if someone know about the what is the meaning of the control mass system, or please if anyone know just for which three question is visible.
No, not visible.
Okay, okay. If anyone know about the control mass system, please chat. Please write in the chat box what is the meaning of the control mass system. Then after I will explain.
System.
So in the control mass system, basically the everything like the identity of the fluid should not be changed in the control mass system, but in the control volume the mass will come and mass will go out with the fixed reason. But in the control mass system itself, the all substance and all molecules present in a system which not change identity at any time. So this is the basic difference between in the control volume system, only the fixed region, the mass will come and mass will go, and but in the control mass system, the identity should not change of the molecules or substance.
What is meant by identity?
Basically, identity meaning here is that the any particular if say the sir was explaining about the of virtual fluid balls in the previous lecture, I think NPTEL lecture. Here identity meaning is that the if the virtual ball is coming and virtual ball is going, some let's say the for example in in a system one virtual ball is present, let's say the number of that virtual ball is 1, uh, that one number of virtual ball is passes through the system, and another virtual ball is coming at that place. So this is the identity changes in the system. But in case of the control mass system, the identity should not change, means the virtual fluid balls should not pass through the system. That is the difference. There is not a big deal with the identity. I think Pradeep,
Yes,
you
yes,
got it.
yes, yes.
Okay, now coming on the next. Yeah, please another one. Also solve the question number one and question number two. And if someone want to the screenshot, please take it. No problem. Now coming on the next questions. Okay. Now I am putting the full view mode, and please go through the first, second, and third question. Here I have taken the uh, basically the 2 year questions of NPTEL fluid mechanics. I think some questions from NPTEL 2021 and some questions from 2022. So please solve the first question. The first question is about the condition of no slip at rigid boundaries applicable to for option number one. And please everyone, if know the answer, please everyone give the answer in your chat box. Yeah, for question number one, the option is the for flow of Newtonian fluids only, and the flow of all real fluids, and the flow of ideal fluid only, and option D is the flow of non-Newtonian fluid only. Yeah, please everyone participates in this session, then we will find. Okay, Pradeep is telling, and Vasant is telling about the for 3 is a twice. Okay, fine. Yeah, please, everyone chat the answer in the chat box. Yeah, for question number one is B is correct. Okay. For question two is a fixed reason in a space, and for three, yeah, I think fine. Three is B, yes, correct. Aditya is telling for three question is for question number three option is B is correct. Yes, fine. Yeah, I think move on the another question. For the question number one, the condition of no slip at the rigid boundary is implies to the flow of all real fluids. That is the option number B is correct. For question number two, a control volume implies a fixed region in a space. That is the option number B is correct for the question number two. And the poise is the unit of dynamic viscosity. Who is telling the kinematic viscosity? So poise is the unit of dynamic viscosity, not for a surface tension and not for the kinematic viscosity. Poise is the unit of dynamic viscosity. You know the Newton second per meter square is the unit of dynamic viscosity. If you convert it in poise, I think 1 by 10. Yeah, if anyone have doubt about the all three question, please ask.
Uh, can you please explain a little bit control volume, if possible?
Control volume.
Yes.
Yes, okay, okay. Let me put it in the full view mode. Yes, Pradeep. The question number two is about
Yeah, I got it. I got it.
wait. You got it?
Yes, yes.
Yeah, okay. I think sir has also explained very well.
Yes, yeah, he has
Uh,
explained this.
yes. Okay. Now moving on the next question. Yes. Question is clear, visible to all of you. Please, if yes, please chat the yes. If all of you are visible, yeah, okay.
Yes, yes.
Question number three is about the match the list and list two and select the correct answer using the code given below. That is the code here meaning the PQRS and 1 2 3 4 5. That is the first P is about the property in which the property which explain the spherical nature of a drop of a fluid, and Q is about the property which explain the cavitation in fluid flow, and R is about the property which explain the rise of water in trees, and property which explain the flow of oil jet. The option one is the viscosity, surface tension, and the compressibility, vapor pressure, and capillarity. If you all go through the I think the sir is explaining very well about the capillarity in all concepts is explaining very well. If you have gone through the all lectures dedicatedly, I think you will get the answer easily. Yes, everyone please chat the answer chat box. And anyone can ask uh, if not visible the questions and not understand the statement of the questions, then you can ask. uh, no issue.
This is there are options A, B, C, D, P3, Q4,
Yeah,
R5, S1. What are they actually?
yes, you are asking about the how to select the answer.
Well, it is written A, B, C, D, then P3, then
Yes,
Q1,
yes, you
Q4.
just match the for the P, which option is correct, option
Correct.
1, 2, 3, 4.
All right, got it. Yeah, yeah.
Yeah, like that. Someone asking about the what is the cavitation in fluid flow. Okay, the cavitation is okay. Before going, I think the question, I will discuss about some concepts. Then we'll go for the questions. The cavitation is not. I think when the vapor pressure is when the pressure is go down the vapor pressure, when in fluid flow, when pressure is go down the vapor pressure, the some bubble formation is happening in the fluid flow, and this bubble when bursted, this bubble force acted on the surface of the conduit or pipe, and due to these forces the some patches formation is happening on the surface of the pipe. This is known as a cavitation. It's a very simple definition. And for your okay, I have some picture for the cavitation. I will show you. Just please answer the question number 3 and question number 4. Then after I will show what is the cavitation. For question number 3, the thing was telling the option number C is correct. Okay, let's see. Let's see which option is correct. And these are the question will help in your gate examination. If someone preparing for gate, then definitely these are the question will help you. I have some of very classical questions, which is coming from the gate, and also you can suppose to come in the gate. Yeah, Matthew is also telling for question number 3, option C is correct. You have another 2 minutes. Please solve the question number 3. Everyone, please participate. Yeah, Mike is telling the option number C is correct also. Okay. Okay, for question number 3, option is C is correct. Yeah, it's fine. Everyone gave the correct answer. For question 4, is someone telling the option number B is correct. Newton second per meter square. If someone have the problem in question number 3, please raise your hand, or you can ask also. Like, okay, I will explain. The property which explain the flow of oil jet in question number 3 of, if you see the S list in list number 1, if you see the S, the property which explain the flow of oil jet, that is the directly related to the viscosity. And one hint I have I want to put here for the option number P, that is the property which explain the spherical nature of a drop of a fluid. That is the, the when sir was dealing about the drop concepts, that is the directly related to the surface tension. And if you know the only single answer for P is option number 2 is correct, then you can easily give the answer. The option C is correct. No need to see the another option. So this type of things in the examination, you can suppose in the examination also. So for your timing, you can optimize the time of that type of mindset. But here you need to go through the all questions and all options here, because here is a no time constraint. Okay, for question number 4, the option number B is Aditya is telling the unit of dynamic viscosity of fluid. Yes, Newton second per meter square. I think everyone know about it. Now move on the next. The question number 5 and 6. With increase of temperature, the viscosity of fluid. The 5 number question was about the viscosity and temperature relationship. And 6 number question is about the continuum approach in fluid mechanics is valid when. The or 4 option is given in the both question. Please chat your answer in the chat box. For both question, you have the 4 5 minutes. For question number 5, Mike is telling the D option is correct. Okay, let's see. Basically, as you all know, the temperature of fluid, basically the fluid is a combination of two things, all the gas and liquid. And in the liquid, the viscosity is directly depend on the cohesion, and in the gas, the viscosity is depend on the random motion of this fluid particle, gas particle. When you increase the temperature of liquid, then the, all about the difference between the the distance between the fluid particle will increase in the liquid case. That is the loss of the cohesion. So that is the loss of cohesion. It means the viscosity also lose. That is the decreases in case of liquid as temperature increases. When you increase the temperature in case of gas, then the random motion will increase, and the definitely when the viscosity, as you know, the viscosities depend on the motion, that is the random motion. So definitely in case of gas will increase. So option number D. For question number 5, the correct answer is goes to option number D. That is correct. And for question number 6, I think sir was telling about, I think in question in the lecture number 2 or 3, the continuum approach. Basically, the fluid mechanics is based on this approach, the continuum approach of the continuum approach. On the basis of the continuum approach, all fluid mechanics equations, that is the partial differential equation and all equations, are derived only based on this continuum approach. So this is the first assumption, or this is the fundamental assumption in the engineering fluid mechanics. Yeah, please chat the answer of question number 6. Yeah, someone is telling the option number C. Okay, Nike is telling option number C is correct. Okay. Yeah, another one please also participates in this session. Then we can feel some. Otherwise, 2 3 participants give the answer. It's not look like the question answer session. Whatever you know, just you think and give the answer, because here you are not getting some extra marks for your certificate kind of thing. Only just you give the answer. There is no issue. Yeah, okay. Now let's move on the next question. For the continuum approach in fluid mechanics is valid when the mean free path of the molecules is much smaller compared to the characteristics or dimensions. Okay. Now the question number 7 and
Can you please explain a little bit the continuum approach? Little bit explain.
okay, okay. I have some slides about it.
Yeah.
If you want, yeah. I think slide is visible, a full view mode.
Yes. Yes.
Okay. The fluid as a continuum here is meaning is that the here you just see the two molecules. You can see. Let me put it the pen. This molecule and this molecule. The characteristic length means here the distance between two molecules. Like in a fluid, just in the box, lots of fluid are there. Fluid particles. Characteristic length means between the two fluid particle, the length between two fluid particle is the characteristics length, and d is here the diameter of the fluid particle. And in case of liquid, it is relatively close as compared to the gas, as you all know. So basically, the continuum approach means here the property of the fluid should not that is the property of fluid should be constant, then we can basically for our study and for deriving the equations, we need some control volume approach, as you know. So we need some specific region. But what is the dimension of a specific region? What is the volume of a specific region? It's depend on the only uh, the continuum approach. If
Yes,
the yeah, so if here you can just see the graph, this density and between the density and volume. If in the region of before 10 to the power minus 9 meter mm cube, before the density is varying lot as compared to the after the 10 to the power minus 9. So here meaning is that we need to select the volume, we need to select the volume for our deriving the equations, like that. The volume should be this 10 to the power minus 9 mm cube. So in that volume, in this type of volume, or these data is here I have written by the books, and these data is written here after the lots of experiment, not only just for sake of understanding. These actual data, this is the actual data written by the lots of experiment. Someone seen at that volume 10 to the power minus 9 mm cube, the fluid property is not varying much. That is the all property follow the continuum, that is the continuous in that volume.
but it must
That is
vary depending on the liquid. It must vary, is it not?
y-
Depending on liquid, like type of liquid.
yes, please, you can.
Depending on type of liquid, it should vary probably.
Yeah,
So
basically the density, yes, yes, basically the here the relation, this relation between the density and volume. So basically the continuum approach means just you for sake of understanding, it is the continuum approach means the fluid properties should not be changed in a particular volume, so we can derive the equation based on that.
yes, yes, yeah.
This is the, and for your better understanding, you can go through the, I think, sir lectures. Definitely you will get some in-depth knowledge about it.
Okay,
Where
yeah.
we, yeah, where we was, I think question number 5 and 6 was done, right? Now we are moving on the question number 7 and 8. Yes, please. Please solve the question number 7 and 8 and give the answer in your in the chat box. The question number 7 is about the shear stress in the Newtonian fluid is proportional to the pressure, strain, strain rate, or the inverse of viscosity. And question number 8 was about, that is the surface tension has the unit of force per unit length, force per unit area, force per unit volume. I cannot say. Okay, for question number 6, option C is correct. Everyone please participate. Everyone give the, at least chat the answer, whatever you know. Because NPTEL, option number 7, C option is correct. Okay. And for option number 6, okay, let's see. Yeah, please, everyone participates. Yeah, for question number 7, the shear stress in the Newtonian fluid is proportional to a strain rate. It's fine. Okay. And in the surface tension, the question number 8, yeah, option number A is everyone goes through. The surface tension has a unit of force per unit length. Okay, it's fine. For question number 8, the surface tension unit is force per unit length. It's fine. Now moving on the next question. Question number 9 and 10. The path traced by single fluid particle is streamline, streak line, path line, or none of the above. And question number 10 is about the flow in which velocity of a fluid at a particular fixed point does not change with time, what is known as the unsteady flow, oscillatory flow, steady flow, and periodic flow. So these questions not only help you in the NPTEL assignment, these questions also help you in your lots of exams like GATE and whatever you are preparing the exam related to civil engineering. These are the questions helping lot. Definitely. So everyone need to the participates in this session. Okay, Aditya is telling for question number 9, option C is correct. Path line. Okay, let's see. And option number 10, the thing is telling the option number C is correct, the steady flow. Okay, let's see. So another 2 minutes are there. So please chat your answer. Yeah, for question number 9, the path traced by the single fluid particle is known as the path line. And for question number 10, the flow in which velocity of a fluid at a particular fixed point does not change with time is known as the steady flow. And you, I think, all know about the unsteady flow and oscillatory flow. If you not know, please go through the lectures. For unsteady flow, just vice versa of the steady flow. That is the fluid property changes at a fixed point with time. Now moving on the next. There is the four option is there, four questions there. Okay, please solve the questions 11, 12, and 13, and also question number 4. The 11, the question number 11 is about a fluid is one which can be defined as a substance. Option A is has the same shear stress at all points, can deform, it is not visible correct my side, can deform uh, indefinitely under the action of the smaller shear force and has the small shear stress in all direction. And last option is about the is practically incompressible. Okay, for question number 10, some Nike is telling the option B is correct. The fluid is one which can be deformed as a substance, can deform indefinitely
Viscosity.
under the action of a smaller shear force. Okay. And if someone have the doubt about the running NPTEL assignment, please you can ask. No problem.
Sir,
Yes, yes.
I have
Aditya.
a doubt regarding this question answer session. There is a session tomorrow also, right?
Yes, Aditya, what you are telling?
Am I not audible properly?
No, I think your voice is echoing. What's happening?
Hello? Is it audible properly? No?
Yeah, audible, but not that much. Yes, please, you can tell again.
Okay, I will write the question in the chat.
Yes, yes. Oh, it's fine. If you can write in the chat box. For question number 12, the kinematic viscosity is defined as the dynamic viscosity into density, dynamic viscosity divided by density, and dynamic viscosity into pressure, the pressure into density. So please, okay, some Nike is telling about the option number B is correct for the 12. Okay, definitely. For kinematic viscosity is defined as the ratio of dynamic viscosity and density. As you all know, this is the very basic knowledge about this fluid mechanics. Now, poise is the unit of, as you all know, the viscosity. What I think this question we have discussed earlier also. And for question number 4, for a fluid, the shear stress was found to be directly proportional to the rate of angular deformation. The fluid is classified as. Aditya is asking my question. Aditya, I think you got this is not this. Some another session will be held tomorrow. That session, the tomorrow session will be held by some another TA, not by you. So for question number four, yes. For question number four, if you know the eliminating, uh, if you know the eliminating concepts of the options, then you can also, by eliminating the option, you can give the answer about the question number four.
Can you little bit explain question number 4? What is it actually? What is angular about deformation?
Yeah, basically, here the angular deformation, as you know, the here angular means the something is rotating. That is the for as you know the for Newtonian fluid, you know about the shear stress is directly proportional to the strain rate. That is the flow is, but strain rate here is the flow water flow not in the angular path, water flow in the straight path, that is the liquid flow, but in the angular the water, the liquid flow or gas flow in the direction of the angular momentum. You know the concept of angular momentum. So here is the angular deformation is this. That is the very basic here meaning the angular deformation.
Yeah,
So for that, the option number D is correct. That is the thixotropic.
that is.
This, yeah, this type of if fluid is follow, this is the uh, this relationship. This type of fluid is known as the thixotropic. Now moving on the next slide. Is this some numericals problem also there? So question number 14 is about a Newtonian fluid is defined as a fluid which is incompressible and non-viscous, obey the Newton's law of viscosity, is highly viscous. Option D is incompressible and non-viscous. I think as you all know the Newtonian fluid, this is the very first definition of the fluid mechanics. Please give your answer in the chat box. For option number 14, the option B is correct. That's good. The Newtonian fluid should follow the Newton's law of viscosity. That is the shear stress is directly proportional to the rate of deformation. Question number 15. Yes, please. Question number 15. You all have the for question number 15, 5 minutes. Please solve.
It's not visible. It's not visible little.
Now it's visible.
Can you read it out or write down?
Okay, the you are telling the not visible.
Yeah, it is smaller actually. It is small.
Okay, okay, okay. Let me put it some another way the my screen. I think
No, that's okay. It's okay. You can read it actually. A bit closer.
okay, if readable, if it's not readable, then I think some another question also in this font. Maybe For another students, the questions are visible. The question number 15 and 16, or I need to put in the another way.
I think did you are there? I can read the question.
Is someone asking about the attendance policy for this kind of session? Or because for attendance purpose, I don't know. Maybe some because for this we don't know about the attendance policy for that. Maybe some PMRF team will tell about it. Okay, now I am read out. Question number 15 is about the two horizontal plate are placed 14 mm apart and the space between them is filled with an oil of viscosity 1.4 Newton second per meter square. If the upper plate move with 2.5 meter per second, the shear stress
Yeah.
in the oil is what? This is the question. Question number 15. These are the very basic questions.
Yeah.
Only relationship, only the relation between the Newtonian fluids, that is the shear stress relationship with shear strain. And you all know the when the distance between two plate is very thin, the relationship how the velocity distribution is happening, that is the linear or curvilinear, you all know. Generally we consider the linear distribution of the velocity between the thin between two thin plate. So based on that concept you can solve these questions, and such type of questions you can expect in your assignments. And also some another exam, this type of questions generally I have seen this type of questions is a lot in the examination also. For question number 15, you solve the question based on that, that is the mu. The mu value is here 1.4 into v is about 2.5, and depth between that 0 point, that is a 14 mm, 0.014. How much you people getting? I think I have calculated. That's 12.4 into 2.5 divided by 0.014. I think option is 250. The correct answer is, please chat, then I will tell. After this question, we take 5 minutes or 10 minutes break. Is it fine for you? If yes, please. Okay. For question number 15, someone telling the 0.094. Is it? I think 0.094 is not. And another student, please reply the answer. You have another 1 minute. Then after I will explain about the question number 15. Yeah, as I explained earlier, the tau is equal to mu v by h. Whatever I am writing, are you people visible or not?
No,
Oh, whatever I am writing, you cannot see.
no, we cannot.
Okay. Oh, I was thinking it was visible to all of you. Okay, let's wait. Okay, I'm trying in another way. Now visible. Hello.
No, you're writing. Oh, yes, oh, yes, little bit, yes,
Yeah, now it's
yes,
visible now.
yes, yes,
Yeah, CLS you all know the relationship between mu and mu is the dynamic viscosity and velocity divided by h. And why I am writing here the velocity divided by h? We are assuming here between the very thin the distance, I think 0 point, that is the 14 mm distance between two plates. This is
yes.
the very thin. So we are assuming the linear variation. So that's why this formula I have written. So mu is given
Yeah.
here 1.4. 1.4 into V is given 2.5 because the upper plate is moving with this 2.5 meter per second, and H is given 14 mm. 14 mm means you need to put the uh, all things in the meter, that is the same units. For 14 mm you need to put the 0.014.
1 4.
So if,
250.
yeah, if you solve, then I have solved, the answer is given the 250.
Yeah,
Yes, now I think everyone got it.
yeah.
Now the question number 16 is was about a liquid of rho density and dynamic viscosity mu. The flow, I think question number 16 is visible to all of you. Yes,
Yes,
please. Yeah.
yeah.
Now another student also unmute and tell. No problem. Okay. Flow and steadily and down a inclined plane. Okay. Inclined plane in a thin sheet of a constant thickness T. The shear stress on the bottom surface due to the liquid flow is okay, where the theta is the angle and plane makes with the horizontal. Okay, the question is about, okay, you people solve, then I will explain about it. So this is the kind of small derivation, not a numeric type of questions. So you people just try, then I will explain about it. And these are the very classical questions of the basics of fluid mechanics, from the basics of fluid mechanics. These type of questions you can see also in the gate examination, previous year gate examination. After this question, we will take some break, 5 minutes or 10 minutes. This is the last question.
Can we draw the diagram of number 16?
Yes, please.
Can we draw the diagram for number 16?
Yes, yes, sure, sure. Sure, I am. Wait, just wait. I am explaining. 16. Yeah. Question number 16 is about, that is a liquid of rho density and dynamic viscosity mu flowing straightly down an inclined plane. That is, some inclined plane is there, and inclination with the horizontal is theta. Here is given, and that is a liquid of density rho and viscosity mu. So here liquid is, let's suppose this is the packet of liquids. Moving downward. So this is the diagram, and the question is asking about the shear stress at the bottom. Shear stress on the bottom, that is the tau is equal to what? This is the asking. The shear stress is, you all know the shear stress, explaining about the shear force, that is a tangential force divided by area. This is the definition of shear stress also. So here the weight of liquid is mg.
Rho GH. Yeah.
Yes, definitely you can say rho z, and the component rho z sin theta in this direction, and other component rho z cos theta. So we are interesting here the shear force, that is the tangential force. So here tangential force is what? Here the weight is about unit density and volume. You all know this relationship, I think. The weight is equal to the unit weight and the volume of material. So unit weight here rho g and volume is the area and height. This is the weight. So we can write here AH also, and here also AH, that is the A here area and H is the height. This indicate the volume. So shear force is, now I am writing here, shear force is rho g AH sin theta and area is A. So this is cancelled out. So rho g H sin theta is the option, is the correct answer. So the correct answer of the 16 is the rho gh sin theta. So this is the very basic, only the component breaking.
So why did you cancel out something?
Yeah, that is the, here you need to the stress, shear stress, the force per unit area. You know the
Yes.
stress
Yes.
definition.
Yes. Yes.
The force is rho g h a sin theta
Yeah.
and area is already here
Okay.
in the
Yeah, I
denominator.
got it.
The
I got it.
area is cancelled.
Yeah.
I think this is a very simple.
Yeah.
So I think everyone, yes,
You
Aditya, you
have,
want to tell something?
yes, sir. You have written height over here, H, but that is not given in the question.
Thickness. Then you use of thickness
Yeah,
also.
yeah, thickness. Here is the meaning of H is thickness, so you can replace the HST. Okay, okay.
Okay,
Sorry for
all
that.
right.
Sorry for that. Just wait. Here the H is replaced by T because in this question the thickness is given T. So rho g T sin theta. Okay, thank you. I think everyone got it. This question number 16. If yes, please chat the yes. Then we'll move for another questions. Yes, if anyone have doubt, you can ask. No problem. I think everyone got it. Okay. Now we take some 5 minute breaks. 5 minute break. Then after we'll move on the question number 5 and 6. If someone want to break, then can go for a break and other. If not, then you can solve the question number 5 and 6. And also we have some another questions. So please 7:20 you need to present. Hello? Hello?
Hello.
Yeah, yeah, please. Okay. Yes, please solve the question number 5 and 6, which is visible on the screen. The question number 5 is about the typical example of an non-Newtonian fluid of pseudoplastic. Variety is water, air, or printing ink or blood. This is just a question related about the examples of the pseudoplastic and another different types of fluids. So if and you can just give the answer, you can just type the answer on the chat box. Hello James, are you solving question? Hello, you are, yeah, you are not audible, James. Yeah, please type your answer in the chat box for question number 5. Someone telling Nike is telling the air pseudoplastic. Okay, let's see for pseudoplastic which option is correct. So not wasting much time on that. The only just is the example. So pseudoplastic for the question number 5, the option number D is correct. The pseudoplastic uh, type of fluid is blood or not air. Moving on question number 6, the shear stress in the Newtonian fluid is proportional to. I think this type of question is repeatable lots of time. Not wasting much time. The shear stress in the Newtonian fluid is proportional to the strain rate, as you all know, or not pressure. Uh, Girl, you are telling about the pressure, not I think. The shear stress in the Newtonian fluid is proportional to or strain rate. That is the, you can also say the del u by del y, and you also say the del theta by del t. James, you can also reply the answer. Now moving on the next. Yeah, option C is correct. Yeah, fine. Option C is correct. Now moving on next question. Yes, please. Here some numericals are there and some questions both. For question number 7, a perfect gas is a perfect fluid or does not have viscosity, is incompressible or does not really exist. That is the perfect gas means here the which follow the ideal law of gas, that is PV equal to nRT. And question number 8 is about the 1 atm here, the atmospheric pressure is equivalent to 1 bar, 1 millibar, and 10 kilobar, and 760 mm of mercury, that is the 760 mm of Hg. Nike is telling the for question number 7, option D is correct. Yeah. Aditya is also telling yes, fine. Does not really exist. For question number 8, uh, one atmospheric pressure is equivalent to 1 bar or 1 millibar, 10 kilopascal or 760 of Hg, that is mercury. Yes, please participate everyone and chat your answer in the chat box. Everyone need to write the answer in the chat box. For question 8, option C, Matthew is telling the option C is okay. Okay, for question number 8, option number C and A, B not correct. The option number D is correct. 760 of mercury. For question number 17, that is the numerical question. You solve within 2-3 minutes. Question number 17. You calculate the specific weight of 1 liter of liquid which weighs 7 Newton. Here the weight of liquid is given the 7 Newton and the volume of liquid is given the 1 liter. So you need to calculate the specific weight for this liquid. And then after in question number 18 you need to calculate the specific gravity for this question. Yes, please everyone solve. I'm also going to solve this question. Question number 17. Specific weight. That is the rho. Volume is given. Yes, please write the answer of this 17 number question. Then after I will explain. Within 2 minutes, you people write the answer of the question number 17. Aditya is telling okay. 7,000 Newton per meter cube. Yes, 7,000 Newton per meter cube. Let me explain how you can get. Okay. The specific weight means here the weight per unit volume. The weight is given the 7 Newton and volume is given the 1 liter. The 1 liter is equal to 7 divided by 1 liter is equal to 10 to the power minus 3 meter cube. So here 7,000 Newton per meter cube is the correct answer. For question number 18 is asking the specific gravity of the above question. Specific gravity, you know the formula of, yeah, someone write the answer, then I will explain. For question number 18, please write the answer in the chat box. Specific gravity. For just a hint, the specific gravity is the ratio of density of any fluid, or you can say the specific weight of any fluid divided by a standard specific weight of the standard fluid. Okay, please anyone write the answer. Okay, let me explain the specific weight, that is the, and as you know the formula of a specific weight is also rho z. So here the 7,000, that is the for a standard, that is the for given liquid, and for a standard fluid it is 1,000 into, you can put it the value of, here for a standard fluid we are considering here water. I think for every specific gravity, in case of liquid we consider the standard liquid as a water. So density of water is 1000 and g value is 9.81. So you can calculate or you can take the 10, no problem. You can also take the value of 10. So here that is the 0.7 is coming as answer, the specific gravity. Yeah, everyone got it? If yes, please type the chat box. If yes, please type in the chat box. Okay, Aditya. Now we are moving on another question. Question number 9 and 12. Question number 9 is about the predominant fluid property associated with cavitation phenomena is a vapor pressure, surface tension, mass density, and none of the above. And for question number 12, the bulk modulus of elasticity K of a liquid is smaller than that of gas. For question number 11, I think question number 11 is not there. Question number 9, okay. For question number 9, yes, yes, okay, no issue. And for question number 12, as I have discussed the earlier, the vapor pressure, the cavitation phenomena is related to the vapor pressure. So for question number 9, the correct answer is goes to option number 1. And for question number 12, just people think and explain and write the answer in the chat box. The bulk modulus of elasticity. Basically, just I want to give some hint. So the bulk modulus meaning here is that the resistance of volumetric or deformation of anything or substance. When you apply the force on any substance, so what is the resistance to resist the deformation in the volumetric sense, not in the single direction, the volumetric in the all over the volume. So this explains the bulk modulus of elasticity. So as you all know, the in the solid case or liquid case, option number C is goes to okay. In case of liquid, the fluid, the molecules of the liquid is having the much distance as compared to the solid. In the case of solid, the distance between the fluid particle is less as compared to the liquid. So when you apply the force on the solid, then the deformation will be less as compared to the volumetric deformation will be less as compared to the liquid. So the bulk modulus of elasticity of a solid is larger that of a liquid. So option number C is correct for the question number 12.
But
Now
generally, sir, generally, sir, it is used for solid bulk modulus. Modulus, I think.
bulk modulus is solid and liquid both. The bulk modulus, let me explain. Some questions are there also about the bulk, but I want to explain something. The bulk modulus is K is the pressure change in pressure divided by volume change in volume. Okay, so this is defined the bulk modulus, and this is definition for the bulk modulus is not only for solid. This is also for liquid, or not only for solid. So this is the formula, and based on this formula, I think some questions. I have some questions. So now move on the next slide. Okay. A fluid is one which can be defined as a substance, has some shear stress at all points, can deform. I think these questions we have discussed already. So question number 11, we focus on the question number 11. The capillary rise of water 20 degrees centigrade in a clean glass tube of 1 mm diameter tube is about. So this question is very interesting, and such type of questions you can expect in your assignment as well as from another examination. A very simple question, but sometimes you forget the formula, so not able to solve. So you someone if chat give the answer in the chat box, then I will explain about. Okay, the Pradeep is telling for question number 12 is not there. 11 number question. Pradeep, you are telling about the 11 number question. Option C.
that is gone already, sir.
Okay, 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 okay. Just for your simplicity, I want to write the formula of 11 number question. That is the capillary rise is H is equal to 4 surface tension cos theta divided by wall divided by rho ZD. Here some data is not there. That is the you know already the surface tension of the water at 20 degrees Celsius. You can take the surface tension 0.07 Newton per meter cube. Newton per meter, not cube, Newton per meter at 20 degrees Celsius. And you all know the angle of contact for clean water and clean glass. The angle of contact between water and clean glass is 0 degree. Theta is equal to 0 degree. So you have left only 4 sigma and rho ZD. The capillary rise force sigma value is sigma here the surface tension indicating 0.07 and rho is equal to 9.81. Not G value is 9.81 and here is a rho, not G, and rho value is 1000 into D value is 1 mm. That is you need to put the 001. After solving I think you will be get how much. Let me write clean here. H is equal to 4 into 0.07 divided by 9.81 into 1000 into 0.001. Yes, please. Someone getting the answer, you unmute and tell. You unmute yourself and tell the answer. No issue. I think capillary rise is coming 0.0285. If we go in mm, 0.5 mm. So always we need to choose the appropriate. That is the most nearest answer. So option number B is correct for this. For question number 11, B is correct. Everyone got? Everyone got it? If yes, please write in the chat box.
The thickness already given in millimeter, so you have to convert to meter. 0.001.
Yeah, because the surface tension value is given, not given here. You know already this is a standard value in the Newton per meter. So we need to all on also the 9.81 is a meter per second square. So every parameters you need to put in the meter, that is the same unit. So I have put it here the in meter because of the G is here 9.81 meter per second square, also the 0.07 Newton per meter, and density is also 1000 kg per meter cube. That's why 0.00. Now moving on the next. Here three questions are there, 13, 14 and 15. The question number 13 is about an amount of glycerin has a volume of 1 cubic meter. That is the volume of this question is given the 1 meter cube. When the pressure is 12, the pressure is 120 kilopascal. That is the pressure is 120 kilopascal. Okay, the volume of glycerin was 1 cubic meter when the pressure was 120 kilopascal. And then another, when the pressure increases from, that is the increases to 400 kilopascal, that is the P2 value is given here. Determine the change in the volume. That is the here the volume is asking the cubic centimeter. You can also calculate in the meter cube, no problem. The delta V is the, that is here you need to calculate the delta V, and the bulk modulus of glycerin is given 0.452. You all know the relationship between the bulk modulus is delta P divided by delta V by V. So here delta P is equal to 400 minus 120 divided by delta V, and V value is given the 1 cubic meter, 1 meter cube, and K value is given 4.52. Gigapascal means 10 to the power 9. So you need to solve the delta V from here. Yes, please, someone solve and write the answer in the chat box. I am also solving. 5.400 minus 120 divided by, yeah, here 400 and 120 is given in the kilopascal. You need to convert in the pascal, so you can multiply both in 1000, 10 to the power 3. So after solving delta V, you will get 0.12340 and 619. So if you, that is the meter cube. If you want to convert in the centimeter, then centimeter cube, then 61.9 centimeter cube is the answer for this question. Yeah, everyone got it? The, if yes, please write in the chat box. Yeah, if you are getting, please write in the chat box. Then we'll move further another question, 14 and 15. These are the last question. Pradeep, you are getting this question?
Oh yes, sir. It's done. Please.
Okay, okay. Now I am moving on the question number 14 and 15. Question number 14 is about the 10 kg plate resting on a very thin film. That is the this is the standard of the film SAE 10 W30 oil, which has a viscosity is this. Here the viscosity you can supposed to change the unit. Dyne second per centimeter square. Only dyne here given. This is the not correct. You need to correct this dyne second per centimeter square. Determine the force P in Newton that must be applied to the center of a plate to slide it over a oil with a constant velocity 0.2 meter per second, and assume the oil thickness 0.1 mm and the velocity profile across the thickness is linear. The bottom of the plate has contact area 0.75 square meter uh, with the oil. So whatever I have explained earlier, the relationship between tau and area, that is a tau and velocity distribution, that is the dynamic viscosity, and V by H. So dynamic viscosity is given here 0.652, and when you convert from the dyne to Newton second per meter square, dyne cent uh, dyne second centimeter square, so how much you will be, I think 10 to the power 5 dyne is equal to 1 Newton. So 1 dyne is equal to 1 5 Newton, that is a 10 to the power minus 5 Newton. So you need to put here the 10 to the power minus 5, and second is same in the both case, and here meter square not meter cube. So centimeter square and centimeter, one, you know, the 1 meter square is equal to 10 to the power 4 centimeter square. So 1 centimeter square is equal to 10 to the power minus 4 meter square. So you need to put here the 10 to the power minus 4. So you will be get the 1 by 10 Newton second per meter square. So here you will be divided by 10. So this unit, the viscosity unit, here is Newton second per meter square. Then velocity you have, I think, yes, 2 meter per second, and the thickness is 1 mm. So you need to put in the 0.1 mm. So you need to put in the meter. Then you calculate the answer. So I think everyone got what I have explaining. 0.0652 into 2 by 0.0001. This is the shear stress. You will be got the shear stress when you will calculate. That is a 1304 Newton per meter square. For force, the shear stress is equal to force by area. For force, you need to calculate the multiply the shear stress into area. So that is a 1304 into 0.75, I think. Yes. When will you multiply it? Then I think 0.75. Yeah. 978 Newton. Hello?
Yes, sir.
Yes, got it?
Yes, sir.
Okay. The question number 18, 15, just I want to explain little bit fast. This and this for a liquid angle of contact. Yes, this question is also about the capillary rise. So
Yes.
you can solve the capillary rise questions easily. If here the already given the capillary rise, only the diameter is asking. So you all know the diameter about. The formula is H is equal to angle of contact is 0 is given. So surface tension is given the 0.4 into 0.06. This is the surface tension. Angle of contact is 0. So cos 0 is equal to 1. And here rho is given how much? 1530. 1530 into G 9.81, and D is asking, and here 2 mm is already there. That is the capillary rise should not be exceed the 2 mm. So here you need to 2 mm put. 2 mm means 2 into 10 to the power minus 3. When we will calculate, I think just for wait, 10 to the power minus 3 divided by 4 into 0.06 divided by 2 into 10 to the power minus 3 into 1530 into 9.81. That is the 0 point, and if 0.0079 0.0079 meter, if you want to put in the mm, that is the 8 mm. 8 mm is the correct answer for the question number 15. I think you everyone got it. The question number 15, Nike. And
We'll solve it, sir. Next time we'll ask you if there is any problem.
okay, question number 15 is not okay. And if I have some another questions, you people, if you want to solve in your home, you can just take the screenshot and just you solve the questions. If someone want, this is a not rule for you. If someone want to the solve the questions, you can take the screenshot,
Yeah.
and this is the another slides. You just take the screenshot and you can write something about it. Then you can easily got it the basic knowledge about the fluid mechanics. and you can also some write the essay problems. And I was having some very interesting diagrams. So today we'll not discuss because we have not much time. Only the time was gone in the question answer session. So this type of I have some presentation for you, but in the next class we will discuss about it. That these are the very interesting, and you can easily feel what is the basics of fluid mechanics, the how the development of the velocity, development length in the flow domain, and how the drag force is working, and also some relationship about the how the drag force on the fees and bird and the velocity distribution, and your the how the different fluids behaving with the, and some question problems I have also. But for next class we will discuss sure.
Yes, sir.
Okay, thank you all
Thank you, sir. Thank you so
for
much.
today. Thank you.
Thank you.
Thank you from my side.
Yep.
Okay.
Yeah.
Okay, bye bye.
I had a question regarding attendance policy.
Yes, Aditya, you are asking something?
I had a question regarding attendance policy. Like tomorrow at 7 p.m. I have another class, and the session is going from 6 p.m. to 8 p.m. So my
Okay.
question is it going to affect my classification exam? Is it going to affect my math and classification exam?
Actually, your voice is not, but I want to explain. You are asking about the tomorrow sessions.
Yes, sir.
So yes, the tomorrow session will be focused. I think your second week is your lecture video is completed for the second week, or still is going on.
Sir, I am still at first week. I am
Okay,
still
second
completing
week
the
is
second.
okay. Second week lecture NPTEL lecture of fluid mechanics is going on.
Yes.
Yes, so maybe your tomorrow session will be on the on only the basics of whatever I have explained. Some another questions the another TA will be explained to all of you. So I think
Okay.
the another session, that is the tomorrow session, will be based on only the first week, and maybe the another tomorrow session will explain some basic concepts about the fluid mechanics, which I have shown to all of you the figure. So maybe this type of things will be done in the tomorrow, but it will be but that will be focused only on the first week, not on the second week.
I was also asking about attendance policy. Like it is just if I am absent in tomorrow's session, will it going to affect my certificate?
For attendance thing, yes, Aditya, you asking about attendance, but for attendance things, I don't know because from the PMRF team and from the NPTL team, no one tell about the attendance. So you can ask to the, I think some mail you have on the portal of the fluid mechanics. You just type and you can ask the question about it for attendance of this session.
Okay, sir. Thank you.
Okay. Okay, Aditya.
Thank you, sir.